If you turn this video at one point off, and please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn Heliology, today Protostars, and after we've done that, we're gonna do extensor carpi ulnaris strength training that lies here. And if you participate in the extensor carpi ulnaris strength training, then it's at your own risk. And this is the second part, the second time that we're reading Protostars. And now we want to go over the text, try to gather the information together, what is given here as a timeline, what happens with the protostar bin, and then make a little presentation for memory out of it. Everything has a prelude, even stars. They are born from vast patches of interstellar fog, light years across, known as giant molecular clouds, which we met briefly in chapter 1. Okay. At the beginning, there are giant molecular clouds. They are light years across and they are consisting of interstellar fog. To recap, these nebula are very patchy. I don't know what patchy means. With some regions denser than others. A denser neighborhood, by virtue of its higher gravity, pulls in material from its surroundings and grows denser still. This increases its gravity even further, which in turn allows it to grow bigger and faster. Okay, at some areas there is more of this nebula interstellar fog of this giant molecular cloud, and it pulls with its gravity more to it. And the more it pulls to it, the denser becomes it, and the more mass has it, and it pulls even more stronger. This increases its gravity even further, which in turn allows it to grow bigger and faster. At the same time, the rotation within the growing cloud fragment causes it to flatten out. And that whole thing, that giant molecular cloud is rotating. And that causes it to flatten out. It was a cloud, it was around. And now it puts together and it starts to turn. The result, around 1 million years later, is a gigantic dusty shell called a globule. And then around 1 million years later, that thing is called a globule. I don't know what a shell is. Yes, it's a shell, an egg shell, but what is it now at a protostar? At the center of this cocoon is a warmer gaseous clump about the size of a current orbit of Mercury, known as a protostar. Okay, it's a globule then. So, giant molecular cloud and then a globule 1 million years later. And then, in the middle, there is a gaseous clump, which warms up with, and that has the size of the orbit of Mercury, so Venus, Mercury, Earth, around the Sun, so much bigger than the Sun, is the gaseous clump. As its name suggests, a protostar is not yet a true star. While the latter is driven by nuclear reactions, a protostar is powered only by gravitational contraction. To understand this process, picture a dam full of water. Contained, the water has gravitational potential, energy that it has by virtue of its influence under Earth's gravity. If the dam bursts, the water gushes out and its potential is unleashed as kinetic energy or energy of motion. In the same way, a protostar is full of potential energy. As it falls in on itself under gravity, its potential energy decreases. If the water of a water dam gushes out, its potential is unleashed as kinetic energy. So then the potential comes away. And when our protostar falls together on itself because of the increasing gravity in the middle, then the potential decreases because now already something has fallen together, but the kinetic energy rises. Why? because kinetic energy is just the energy of motion. And it is just falling onto itself together, so it's kinetic energy. And that rises in the form of heat, and that makes the contracting protostar warmer and warmer. So, what is it? Why do you get it warm? Because of the gravity, it is falling together. And now the potential energy of the gravity falls, because it's now already fallen in, but at the same time the kinetic energy, so the energy of motion, rises because it's falling. But it can't be the whole energy coming just from the falling together. It seems not enough, because it's just one time. Or is it falling faster and faster? But why can that make so much energy for a sun if it's technically just one time falling together? And it seems to be not so vast to fall together. It's just the size of the orbit of Mercury. The gas in the middle, light years across. Light years. Let's think about it in one moment. Light years. We're not talking about light minutes like the solar system. That thing is light years across. Now it makes sense. So the gaseous clump in the middle is as big as the orbit of Mercury. So there's a big sun in the middle, a big distance to the Earth. That are around, so let's say to Mercury, around 6 minutes of light. Very big, but certainly not massively big. But this is the gas in the middle. The giant molecular cloud is light years across. Plural. The light from the sun to Mercury or to the Earth needs around 6 or 8 minutes to Mercury. It's around 8 minutes. The solar nebula is a year big. That thing is very, very much bigger than the solar system. Now it makes sense. If that big thing, very, very much bigger than the sun, or than the solar system with the sun and all the planets in it, falls together, that has enough energy to make in the middle a burning bubble. Let's think about it in 8 minutes, at 1/6 of an hour. So we're having around 100 a day. Let's take 100 a day. That is 300 times 10, so 3,000, 6,000, 8,000 hours times 8, times 6. So 50,000 times as big if it is singular. This giant molecular cloud is 50,000 times as big as the solar system, at least from Earth to the Sun. If it's singular, it could be light years, and then it's much more. (300 times 10 of 3,000), never 10 for the hour, 10 hours. I know 6,000, so let's take 8,000. It's 8,000 hours a year, and we're having 6 of them, so 48,000. So 50,000 times as big as from Earth to the Sun would be 1 light year. That thing is 50,000 times as big as the Sun in the middle, and then there's for a lot of time nothing to the Earth, for a very long time, for 8 light minutes. And that thing falling together has enough energy. So now can I understand, I cannot picture something with the size of the Sun to Earth or something like that falls once together and now it burns for billions of years. But if the thing is 50,000 times as big as the solar system and falls together, that has enough friction, kinetic energy, potential energy, whatever, to cause that. Okay, it has a potential energy because it is there and it can fall together. Now, through the gravity, it falls now together. And while it falls together, there is now a lot of motion happening, and the energy of motion is kinetic energy, and so the kinetic energy rises in the form of heat. It's just always falling together. It's 1 light year would be 50,000 times as big as the size of the solar system from the Sun to Earth. At least, and the whole thing is so big, or was. The protostar stage does not last long. After about 100,000 years, the object becomes warm enough for the heat it generates to start to vaporize its birth core. I don't really know what vaporize means. Water is vaporizing. So we're saying it's vaporizing its birth core. The birth core was the gas in the middle. I don't really get it. After that lasts for 100,000 years, then it's very hot, and gradually it unveils itself to the universe as a huge luminous mass, glowing like a dull red ember. Is ember a wood? We don't know what ember is. The gravitational contraction continues until around 1 million years later. The protostar's core temperature nears 5 million degrees Celsius. As this preludes to the stellar object's life as a true star draws to close, it is set to enter a period of turmoil. As this prelude to the stellar object's life as a true star draws to close, it is set to enter a period of turmoil. Okay, Protostar. After 100,000 years, it is in the middle so hot and it starts to glow. A luminous mass, it's a big luminous glowing mass. It continues for 1 million years to fall onto itself, and then in the center it has 5 million degrees Celsius, and basically... now, the little problem is, if I make now a video about the protostar, comes now the next thing. Now comes the T-Tauri phase. Let's just make the presentation, having back in mind that the next stage is not the sun or star, but the T-Tauri phase. But it is the phase of protostar. I'm going to start the... Why am I doing that? We are behind time. We are behind time. We are behind time. Which means we're going to do another part in Heliology. There we're going to do make a presentation about protostars. Maybe you're going to read first the T-Tauri phase. It is also ready. And then the next phase, and then we come back and make our presentations. Whatever, we're going to continue the next part in Heliology with Heliology. If you were here for Heliology, you can go to mention Heliology part. If you stay here and participate in the extensor carpet on our strength training, then it's already obvious. Go in stable stance, hands next to us and hands front to fists. Bring the fists down and up, and that is the floodgate. We have a lot of potential energy, which is released as kinetic energy as soon as it moves out. And now the next exercise, the counterfeit money check. Hands like this and bring them up. And now, we're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. The second rule is that we're going only as fast as we can go with a little bit of effort. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. You can use a sock, a t-shirt, a towel, have it in hand and press with good moderate force onto it. Not bring the fist hand in front. And back. Handing in front. And back. Alright, press with good force. Bring the hand. Now, change again, press good and turn to the outside. Only as far as it goes, painless, and to the inside. Press with all 5 fingers evenly. We want to train the extensor carpi linaris, so press with the 4th and 5th finger evenly. Last time to the inside. Now change, press, and to the inside. And change. And now hold from the top, press, and back and down. And on the other side, press, and now just press in roller position. And with your right. That was the extended carpet and now strength training. Thank you very much and